So now we can go over some nomenclature as it relates to alcohols, ethers, and thiols. Our first example here is this 7-carbon parent chain with the alcohol at carbon 2. Recall that numbering becomes easier for alcohols than it did when we were just working with alkanes, because numbering for alcohols means that we put the number closest to the alcohol. We start at the end closest to the alcohol. From here, we just have a bunch of methyl groups. So we have 3, 5, 6 trimethyl, two heptanol. You might be wondering about stereochemistry because this molecule actually has several stereocenters in it. But because I haven't indicated a direction for any of the bonds, we can't do stereochemistry here. I just wanted you to look at the name without it here. All right, number 2 being in a ring, we know that we're going to start number 1 at the alcohol and then go in the direction that has a substituent closest. So cyclohexanol. And that's going to be 5-isopropyl, 2-pentyl cyclohexanol. But now we have indicated the stereochemistry for each group, and so we have to include that as part of our name. In fact, we have 3 chiral centers, 1, 2, and 5. At carbon 1, the alcohol gets higher priority than the carbon groups. And then the carbon down below is higher priority than the one to the left because of the extra substituent. So that's 1R. Down here at 2, our highest priority group is the one up at the top because that's a carbon attached to oxygen, whereas the other 2 are carbons attached to carbons. 2 here, 3 here, it's 2S. And then finally at 5, we have first, second, third. Clockwise is 5R. Question 3, we start over here at the alcohol end. So this is nonane, but we also have to include the 2 alkenes. So nona, 2,6-diene, 1-ol. For this one, we do have to put the number for the alcohol in the middle of the name because we have multiple functional groups within the parent name. We also have our substituents, 2-bromo, 4,4,8-trimethyl. What about stereochemistry? Well, carbons 4 and 8 are not chiral because they both have 2 identical substituents. But we do have our alkenes. And so carbon 2, we have Z, and carbon 6, E. Number 4, we start on the right because that means we have an alcohol at 1 and the second alcohol at 1. Whereas if we start on the left, our first alcohol is not until carbon 2. So we have a 7-carbon chain. So that's heptane. there's 2 alkenes at 1 and 5, so that's hepta 1,5-diene. And then there's 5 alcohols at 1, 1, 2, 5, 6, so that's 1, 1, 2, 5, 6 pentaol. Our substituents, carbon 4 is a 7-membered ring, so that's 4 cycloheptyl, and then 3 methyl. For stereochemistry, the alkene at carbon 1 has 2 identical substituents on one side, so we can't do E and Z there. Three is chiral, 4 is chiral, and then the alkene at 5, we can see our higher priority groups, the OHs, are on opposite sides, so that's 5E. We can then do our chiral centers. Carbon 3 here, the methyl is 3rd priority, the carbon bonded to oxygen is 1st, and the carbon bonded to other carbons is 2nd. It gives us 3S. And here we have 1st priority, 2nd, and 3rd, also S. Alright, for this one, we're going to start all the way on the left, because that again gives our alcohol the lowest possible number. So that's decane, and it's going to be deca 6,8-diene, 1-ine, and then the 3 alcohols are 1, 4, and 5 triol. Other substituents, just the cyclohexane ring at carbon 3, so those 3 cyclohexyl. And then finally, for our stereochemistry, we have a chiral center at 3, we have an alkene at 4, an alkene at 6, and an alkene at 8. 8 is Z, we have 6E, we also have 4E, and our chiral center, highest priority is the carbon to the right because it's bonded to oxygen. Second priority is the carbon to the left because it's a carbon that we count as being bonded to 3 carbons, whereas this is a carbon bonded to 2 carbons. Arrow goes counterclockwise, but we take the opposite because the lowest priority group, the hydrogen, points forward, so we have 3R. Right, now we have some ethers and thiols to look at. Number 1 is, when we have the very simple R groups, we just name the 2 R groups. So cyclohexyl on one side of the oxygen, isopropyl on the other side. We put them in alphabetical order, and then we just put ether at the end. Number 2 is more complex, so we just name the ether as a substituent. The ether does not get any special priority over other groups, so we number this one based on the alkenes, making it octa 1,3,5-triene, and our substituent is the 8-methoxy. Don't forget our stereochemistry, which those 2 alkenes, 3 and 5, we can see are both E. Same type of situation in number 4. This is a more or number 3. This is a more complex ether. So we just name them as substituents. So our numbering is based on the alkyne here. And so this is 1 hexyne. For substituents, we have the 2 ether groups, so it's 4,5-diethoxy. And then we just need to indicate the stereochemistry at 4 and 5. 4 is R, and 5 is R as well. Number 4, our numbering starts here because it's going to be determined by the alkenes. And going there not only gives us the lowest numbers for the alkenes, but also gives us a low number for one of the substituents. So we have 6 bromo, 6 chloro, 1,3-diethoxy, 5-methoxy, cyclohexa, 1,3-diene. Now we're going to need R and S for carbons 5 and 6, but we don't need to do E and Z here. And the reason is because these alkenes are in a ring. And when you're working with a ring this small, basically anything under 8 carbons, there's only one possible geometry for the alkenes anyway, so we don't need to indicate it. Now, carbon 5, which is where the methoxy group is, the oxygen is highest priority, followed by the carbon bonded to bromine and chlorine, and this carbon. So we have 5s. At the other carbon, bromine is first priority, chlorine is second. Third priority is here because this is a carbon that counts as being bonded to 2 carbons and 1 oxygen, while the one up here counts as being bonded to 1 oxygen, 1 carbon, and 1 hydrogen. Now this one's more challenging and is where a model kit will definitely benefit you, but you've basically got to be able to look at this and picture it so that that carbon-carbon bond up to here, so that that one's pointing away from you. If you do that, you find that your arrow goes clockwise and you get 6R. Number 5 is a thiol. That's the only functional group here, so we number it based on the thiol. So we have 6-methyl, 2-heptane thiol. The carbon with the thiol on it is chiral. Priorities are 1, 2, and 3, and so it would be R. And finally, in number 6, the alcohol is our priority group here. So we number it starting closest to the alcohol end. So this is hepta 2, 3, 4 triol. And then the ether and thiol both get named as substituents. So this is 6 mercapto and 5 methoxy. The biggest challenge left on this one is there's actually 5 chiral centers in a 7 carbon chain, and so we would need to go through each one of these what I will do is just for each one of these, I will draw in the priority so that you have them. And there you have it.